Today we're going to find the static coefficient of friction for a piece of bread. And before we begin, we need to define exactly what friction is. Basically, friction is a force that resists a sliding motion between two different surfaces. So for example, here I have a block on top of a plane, and we're trying to move that block forward using the force P. Now the force of friction, which is this force here, works against P and makes it harder to move the block forward. Now I might be wondering why friction happens, even if the two surfaces appear to be perfectly smooth. And while they might look smooth and feel smooth, in reality they're actually not. And to see what I mean, we have to take a much closer look at the two surfaces. At this scale, it's easy to see that the two surfaces are actually quite rough, with ridges that bump into crests every time we try to slide one surface across the other. And this is exactly why friction occurs. Friction is largely dependent on what's known as the coefficient of friction, which is just a number that represents how easy or difficult it is to slide one surface across another. Here's a chart that shows a bunch of different coefficients of friction for different surfaces. And just by looking at this chart, we can see that it's much harder to slide aluminum across dry aluminum than to slide it across dry steel. And it's much easier to slide aluminum across lubricated aluminum than across lubricated steel. Now we can easily find the force of friction as long as we know the coefficient of friction between the two different surfaces. So to calculate the static coefficient of friction between the two surfaces, we need to find the angle at which they start to slip. So to do that, I will have my assistant slowly raise the board, and while she's raising the board, I'll have my phone here, which has a protractor on it, which will tell me the angle, and she'll start to lift it, like so, and then once it starts to slide down the board, I'll read off the angle and write it down in my notebook over there. So, to start off, we're going to do wood on wood, like so. Could you please lift? Thank you. We're up to about 20 degrees. And that was 41. Oh. Next up is bread. Now I suspect that this is going to be a lot more than 40 degrees, so I'm going to help you out here by holding it down here by doing that. Up to 30 degrees so far. 40. 50. Oh, 54 or 53. Actually, it looks like it was between 52 and 54, so I'll put down 53. Now we're going to switch out this wood for this aluminum plate, and we're going to repeat the same thing again. Alright. Oh, that was about 24. Yep. Move it over here a bit. $50, $60, $64. Now, in order to make sure that our numbers are all accurate, we're going to do this 4 more times and take the average of those, and we should get a more accurate number. Now, we don't need to do this on camera, so we'll just do that off camera. Now that we have all our angles, we can find the static coefficient of friction. And the first step is plugging in our numbers into this table here, starting with wood on wood. The first reading was 41 degrees. The second reading was 40 degrees. The third reading is 38 degrees. The fourth reading is 41 degrees. And the fifth reading is 40 degrees. To get the average, we type in equals average column B2 to column F2. Hit enter, and now we have our average. Next up is bread on wood. The first reading was 53 degrees, the second reading was 55 degrees, the third reading was 54 degrees, the fourth reading was 58 degrees, and the fifth reading is 61 degrees. And the neat thing is we don't have to put in the formula again, because we can just take this, drag it down, and it does this for us automatically. Now we get some weird things happening here, but that's because we haven't put any data into these columns yet. Let's do that now. For wood on aluminum, the first reading was 24 degrees, the second reading was 25 degrees, the third reading was 24 degrees, the fourth reading is 20 degrees, and the fifth reading is 24 degrees. And as we put the numbers in, it automatically did the calculation. Next up is bread on aluminum. The first reading is 64 degrees. The second reading is 66 degrees. The third reading is 66 degrees again. The fourth reading is 67 degrees. And the fifth reading is 62 degrees. And now we have all our averages for each of the different angles. Now that we have all our angles, we need to convert them from degrees to radians. And the reason for that is because this program is expecting all the angles to be measured in radians. So if you go to take the cosine of an angle, it's going to assume that angle is being measured in radians. But if all your angles are being measured in degrees, then you're going to start crashing Mars climate orbiters into the surface of Mars, and everyone is sad. We don't want that, so that's why we have to convert them from degrees to radians. And to do that, we type in equals pi times column G2 divided by 180. And that gives us our angle measured in radians. Now we just need to drag this down, and all our angles are converted into radians. The last step is to take the inverse tangent of this angle, and that will actually give us our static coefficient of friction for the material. To do that, we type equals atan column H2, enter, and that gives us our number. Then we just have to drag it down, and now we have the static coefficients of friction for each of the different materials. Looking back at the chart from earlier, we can see that the numbers that I got weren't actually that far off from the real numbers. So the value I got for wood on wood is approximately 0.61, and the value for wood on wood is somewhere between 0.25 and 0.5. Now I think the reason why my numbers were so much higher than the actual numbers is because the two boards weren't sanded very much. And I think one of the boards even had some pine pitch on it, which would obviously increase the static coefficient of friction. But I think I still got pretty close. The value I got for wood on aluminum is approximately 0.39, and the value for wood on metal is somewhere between 0.2 and 0.6. And my number actually falls in between that range, which means that my number is actually pretty accurate. So to summarize, to find the static coefficient of friction between two surfaces, all you have to do is find the angle at which one surface starts to slip, then take the inverse tangent of that angle, and that gives you the approximate static coefficient of friction for the two surfaces.